Welcome back to the series. Today we have Kevin back with us to show us one of Hamamatsu's compact spectral sensors. So Kevin, can you give us a bit more information on what you'll be talking about today?
Well, today I'm going to be demonstrating the Hamamatsu MEMS-FPI Module and how this can be used with our evaluation software Tokuspec. This module contains a Hamamatsu MEMS-FPI sensor, a built-in light source and a control circuit. This allows plug-and-play measurements to be performed with ease. All you need to do is connect the module to a laptop via USB. The compact nature of this device allows easy use at a lower cost than traditional FPI devices.
So what can this module be used for?
Well, with options for sensitivity across various bands of the infrared range, the MEMS-FPI can be used to observe key absorption lines for water, organic compounds and inorganic compounds. This means it can be used for many applications, including moisture detection in skin or other materials, detection and analysis of organic compounds or even synthetic contaminants in agricultural and food products, plastic sorting and identification of various synthetics and fabrics.
So how does it work?
To understand how this module works, we need to look at the sensor inside. This is of course the MEMS-FPI sensor. These are ultra-compact sensors that house an in-gas pin photodiode and a Fabry-Perot interferometer, or MEMS-FPI, tunable filter that can vary its transmission wavelength depending on the applied voltage. In this structure, the photosensor and the tunable filter are arranged on the same axis as the incident line. By using a tunable filter, this device is able to be a spectral sensor while only using a single point detector and not an expensive multi-channel sensor. The tunable filter is designed with an upper mirror and a lower mirror that are placed opposite each other with an air gap in between. The upper mirror has a thin membrane structure to allow the mirror to move. It's moved when a voltage is applied across the mirrors, creating an electrostatic force that in turn adjusts the air gap. Based on the exact size of the air gap, it functions as a filter that allows only a specific wavelength to pass through. Increasing the filter control voltage narrows the air gap, which causes the peak transmission wavelength to shift to a shorter wavelength. Silicon is used as the substrate of this device as it operates as an infrared transmitting filter. The mirrors are constructed as multi-layered dielectric coatings of typical semiconductor materials. The module we have here combines this sensor with a built-in light source to allow us to perform reflectance measurements with ease.
What are we going to be doing with this demo today?
Today we're going to be looking at some different types of plastic and showing how the MEMS-FPI module can be used to differentiate between them. We'll be looking at polypropylene, or PP, polyvinyl chloride, or PVC, and polyethylene terephthalate, or PET. These are three very common plastics that you can find in everyday life. The examples of these plastic that we have here today are a plastic bag, some cling film, and a laminating pouch. These three plastics, while sharing some similar properties such as flexibility, colour and texture, have very different absorption characteristics for infrared light. By using the module, we'll be able to look at the spectra for each one and see the differences between them. To get us started, all we have to do is open the Tokuspec evaluation software. This software is designed to work with all Hamamatsu spectrometers and spectroscopic devices. Once this software is open, we ensure that the connection to the model C15713 is activated. Once we've done this, all we need to do is go to the measurement settings and activate the lamp in the device. Once the lamp is on, we can now take our snapshots of the spectra. To do this, you simply select Snap. So we place our module on our first sample, and we've taken the first spectra. To get the spectra of the other two samples, all we need to do is repeat this process. We now have our three spectra for our three plastic samples. As you can see, whilst sharing some similar characteristics, they are all different. So there we have it. Today we've seen how quick and easy it is to distinguish between different materials with the Hamamatsu MEMS-FPI module, and a look at the Tokuspec evaluation software. To find out more about the MEMS-FPI module, Tokuspec, or any of our other spectroscopic solutions, get in touch.